The internet is full of IP address,
Yes.
and it's not one network. It is millions of network together forming an internet. So each
Mm.
network is identified with unique address, which is an IP address. And
Mm-hmm.
and to connect between this millions of network, we need smart devices. They are
Mm-hmm.
called routers. Routers can navigate our packets to the right destination because the routers know which network is in which direction and how far to go. So
Mm-hmm.
the smart device router keeps track of every network around the world and maintains the path information. We call it as a routing table. That path information is updated dynamically using routing protocols.
Yes.
Now, if you don't like routing protocol, then you need to configure the routers with manually writing the routes.
Mm-hmm.
We call it a static route, which is not possible in a large network.
Mm-hmm. Correct.
We have to depend on dynamic routing protocols like border gateway protocol, open shortest path
OSPF,
first,
AGRP.
routing information protocol. This and then ISIS, intermediate system to intermediate. These are all industry standard protocol.
Mm-hmm.
And Cisco also has got a version called IGRP, which is old version, another version called
AGR.
EIGRP.
Mm-hmm.
Now, these two are not that popular, and this is the older version of this.
Mm-hmm.
And even
But
Cisco,
AGRP is industry is using, right? Extensively.
no. See, Cisco made it as open standard,
Mm-hmm.
but still not many vendors got
Mm-hmm.
EIGRP. Only Cisco device will have EIGRP.
Mm-hmm.
And even on the Cisco router, people don't like to enable EIGRP because they have mixed vendor devices, mixed vendor routers. So they run
Mm-hmm.
OSPF instead of EIGRP. If they run EIGRP, then some routers may not support EIGRP for them because they're not uh, Cisco's.
Mm-hmm.
Some routers are not Cisco's.
Okay.
Right. So routing packets from one network to another
Mm-hmm.
needs router,
Mm-hmm.
and router needs routing table,
Mm-hmm.
and routing table needs route, and that route can be given statically or by using routing protocol.
Mm-hmm. Yeah.
Yeah. So static or static route or routing protocol, which one? It depends on how big the network is.
Mm-hmm.
In a small network, instead of we running a routing protocol which will consume the CPU, instead of running routing protocol which will consume CPU,
Mm-hmm.
we can write static route. Routing
Right.
protocol, of course, they will consume CPU because they send some hello packets every now and then. If you take OSPF, OSPF will send hello packet every 10 seconds, which means that all router will process this packet called hello every 10 seconds, and then they need to maintain the database called link state database, which is going to give a very clear picture of about topology, information, and so on. So what I'm trying to say here is small network like 2-3 routers.
Mm-hmm.
Very well you can go with static route
Mm-hmm.
because only 2-3 routers, and you can easily configure routes. You won't have too many networks, maybe 10 networks in your organization with 3 routers. You don't need really a big routing protocol. If you want, you can enable, but that is what I'm trying to say. If you are comfortable with dynamic routing protocol, go ahead. Even if it is small network, it is okay.
Got it.
So that if something goes wrong with the link, you don't need to worry about. The routing
Mm-hmm.
protocol will converge. Even in your sleeping time, there won't be a problem. But if you use a static route, when the route goes down, when the path gets broken, the alternate path
Mm-hmm.
will not get installed because it's a static route. You need to wake up from the sleep, log into the router, remove the old static route, write a newer one, uh, matching the new change in the topology. So static route is not a recommended solution for high availability and scale
Mm-hmm.
and also for scalability. But as a first routing topic, we're going to learn static route.
Mm-hmm.
After which we will get into routing protocols.
Mm-hmm.
Writing static route is very simple. Have you worked with Cisco routers before?
Yeah,
Okay, so you know
I'm still working,
you,
no?
you know the
Mm-hmm.
commands.
Yeah.
Okay, I'll just take 3 routers, and
Mm-hmm.
let's say I got a network 2.2.2.2/32 on the loopback, and another
Mm-hmm.
loopback 22.22.22.22/32, and I connect like this, and this is R3, and this is R2, and this is R1. And you got 3.3.3.3/32 and 1.1.1.1/32. Now let us take a network in between these two, 10.12.0.0/16, 10.23.0.0/16. Dot 1 here, dot 2 here, dot 2 here, dot 3 here. And I would like to name this interface with Ethernet 0,
Mm-hmm.
Ethernet 0, Ethernet 1, Ethernet 0, Ethernet 1. Sorry, this is loopback. Our loopback interface are not physical. We are just
Yeah.
creating that interface to have a network there. I don't want to connect a
Mm.
wire and no, this is just for a lab environment. I don't want to connect a wire and do testing, which is going to be time consuming. So we take, a simple logical interface in order to have a network. I want to have a network 2222 and 2222.
Mm-hmm.
So I create two loopbacks on router 2. So the routing
Yes.
table will have those two networks. Now,
Mm-hmm.
R1, okay, I don't want this subnet in network. Okay, it's okay. So if you take R1, R1 knows only about two network. So in the routing table
Mm-hmm.
of R1, if you check, you will have 1.1.1.1 /32 connected on this loopback. And then 10.12.0.0/16 connected on Ethernet 0. And then in R2, if you see, you got 4 connected networks. One is loopback 0, another one is loopback 1, another one is Ethernet 0, another one is Ethernet 1. Loopback 0, I got 2.2.2.2/32, and then 22.22.22.22/32, and then 10.23.0.0/16 on Ethernet 1.
That is even.
On Ethernet 0, it is 10.12.0.0/16. Actually, these interfaces should be on the last. Yeah.
Which one? Yeah, correct.
Likewise, on the third router, we got loopback
Two
3.3.3.3 connected 3.3.3.3/32 on loopback 0, and then on Ethernet 0, 10.23.0.0/16 on Ethernet 0. Now, if someone tries to reach 3333 from here, let's say someone is sending a traffic, and the destination of the packet is 3.3.3.3. Now, the router cannot forward the packet. Why? Because the router don't know where is 3333. So
Correct.
either you need to write a static route or enable a dynamic routing protocol. Our aim is to write a static route. Now, writing static route can be done in 2 ways. One, you can say in order to go to that 2.2.2.2 or 3.3.3.3, you go to next router. For router 1, router 2 is the only gateway. What is gateway? The address, the router's address, which will take responsibility of moving your packet to the final destination. Can R1 move the packet to the final destination by itself? No. It depends on the next guy. And that router 2 will depend on router 3. So for router 2, router 3 is the gateway. For router 1, router 2 is the gateway. So you can write gateway address, or if you don't know the address of the next router, if you don't know this address, you can also say go out on this E0. Just say go out on this in E0, and it can be easily discovered.
Yeah.
Okay. So what we are going to do is we're going to do 2 ways of writing static route. First, let me on R1, what I'll do is I'll write like this IP route. In order to go to 3.3.3.3, 255.255.255.255, send the traffic to 10.12.0.2. You know whose address is this? Address of router 2.
0.2. Yeah, correct.
This is one way. The other way is IP route 3.3.3.3, 255.255.255.255. Send it out on E0. Okay. Oh no. God. Got deleted. It's okay. You got the point, right? No, it didn't work. And I didn't do it. Didn't work. Okay. So, what is the difference? See, saying how to exit is one method. Another method is saying which address to deliver. Which one is good? Actually, both are good. If you know the next router's address, you give next router's address. If you don't know the next router's address, router 1 will look into the ARP table and see which address is the next. On Ethernet, on Ethernet E0, you have 10.12. In the ARP table, it will see what are the address that is got 10.12. It will find 10.12.0.2, this address. So it will use the MAC address of this and it will send here. Both are same.
So this will happen only if we add the static route, correct?
Okay, so you can write static route either by saying the exit interface or by giving the address of the next hop.
Yeah. So, sir, one question. So, if we didn't give static route, but still ARP table might have learned R2's interface.
But unless you tell that for this network you need to go to that address, it won't go. See, the next hop address is known to the ARP table. But how router 1 knows that the next hop is a router which can take you to 3.3.3.3? It can also be a computer, isn't it? 10.0, 10.12.0.2 can also be a computer. So unless you write a route and tell that you can go out on E0, it will not know. It will not try. I have to tell. It won't go and copy anything directly without you telling from the ARP table. Only when you don't use the next hop address. Instead, you gave an exit interface name. Only in that case, it will know the next hop from its ARP table.
ARP table. Okay. Sir, one question. So, if the high-end routers, they have this ability to derive the route when we issue the IP address. Say, for example, R1 E0, we are assigning an IP address. So from there, it will derive the route and install into routing table. Is this possible?
Say again.
In case of R1, say for Ethernet interface 0, we are assigning an IP address. So from that IP address, this router can derive this route information and install into the routing table. Is that possible?
No. Can you repeat again? I still didn't get your question fully. I want to make sure what you are asking.
Yeah. So my question is like we are assigning an IP address to interface. Yes. E0 of
so
R1.
Automatically from that IP address, this line will come. This is not a statically given line. This is dynamically. From the subnet mask, you might have given 10.12.0.0.1, but it will take this network of it and put it here, not the IP network. Yes, it is automatically, yes.
Network. So is this enough or on top of that we have to write?
You need not to write for connected networks. You need not to write for connected networks. You need to write only for the networks that are not on this router. This router knows the directly connected network. So whatever I have already written in the routing table is already learned dynamically based on the IP address that you assigned. Okay, so let us go to a command line and try doing that. Before that, I want to finish one more small topic. What is that? You see, static route is a writing route to reach every destination. So how many destinations that R1 do not know? No, I'm asking question. R1, how many destinations R1 do not know?
R1 do not know 2.2.2.2
Totally how many?
22.22 that so then total how
No,
it will
one
be
more is
4.
there.
2
Oh, no, no,
10.12
one,
oh
two,
no
three, four.
10.12
Correct, correct. 4. Okay, 4. So
mm-hmm.
I need to write 4 static route in R1. Likewise, in R3 also I need to
Mm-hmm.
write 4 static route. In R2 I need
Mm-hmm.
to write
Correct.
2 static route. Fine.
Mm.
You can do that. Or on the edge
Mm-hmm.
routers, see R1 is an edge router.
Mm-hmm.
Likewise, R3 is also a edge router.
Edge router.
Now
Mm.
R1 and R3, these two routers, they no need to have a detailed route. Why? Whether you write detailed route or a default route, which is called NEA, you need to send it to R2.
Mm-hmm.
See, whether it is 100 network or 5 network, where you will be sending all those packets? Only R2 only.
To R2 only.
So instead of we writing
Mm-hmm.
separate line for each
Mm-hmm.
network saying static
Mm-hmm.
3 network, static go via E0. Again static 22 network go via E0. Again static 2 network go via E0. Again
Mm-hmm.
static 10.23 network go via. Instead of writing these many lines,
Mm-hmm.
we can simply say any network that this router does not know, we call it as star, means default, S star,
Mm-hmm.
static default. We can say anything that you do not know, whatever the subnet mask may be, any destination you
Mm-hmm.
don't know, simply send it out via E0. This is what called as default
Mm-hmm.
route. So you can write this default route on the stub routers, meaning what is stub router? The router that has got only one exit, just only
Exit.
one
One
gateway.
gateway. Mm.
That is why I cannot write it on R2.
Mm-hmm.
Why? R2 has got 2 gateway.
2 gateways. Yes.
So we can mix both default route and the static route if you have 2 gateway. Say for example, on R2 I can write default route for one direction and static route for another direction. That is okay.
Mm-hmm.
But only default route will come if you have stub route. If you have only one
Mm-hmm.
gateway, it is
Stub.
what stub.
Mm-hmm.
Stub means
Stub means
only one
mm-hmm.
gateway.
Okay.
Stub router means what? Only one
Mm-hmm.
exit. Only one exit for
Yeah.
all remote destinations. If you have only one exit,
Mm-hmm.
R2 has got 2 exit. 1.1.1.1, go to R1. 3.3.3.3, go to
Mm-hmm.
R3. 2 different
Got
direction.
R3. Mm-hmm.
Then it is not a stub router.
Mm-hmm.
It's not a stub router at all.
Mm-hmm.
Right. Now, we are going to do this lab. How many? 3
Okay.
routers. And we are going to use packet tracer for this. We can
Mm-hmm.
also use EVE, but have you installed EVE?
No,
You've
I
installed
didn't
it.
install
Okay,
yet.
no problem. I'll use the packet tracer to do this now.